For almost 20 years, the dream of flying faster than sound was silent. The Concorde was gone, the skies slowed down, but now, a new generation of engineers and dreamers wants to bring supersonic travel back. Hello everyone, my name is Matt and this is Invented, the place where we break down the coolest innovations that are changing our world. From the 1950s to the 70s, every nation wanted the fastest jet. Engineers in Britain, France, the Soviet Union, and the United States all raced to go beyond Mach 1. For the first time, the idea of global travel in hours felt real. In the early days of aviation, speed was everything, from propellers to jet engines. Every leap forward was about flying faster. And then, in 1976, we broke a barrier. Concorde took off, the first commercial supersonic jet, London to New York in just over 3 hours. Concorde used a delta wing to stay stable at supersonic speed. It changed the angle of its nose during takeoff so pilots could see the runway. It was one of the most complex mechanical designs ever made for a passenger jet. It was elegant, it was loud, and it was expensive. Concorde was not just a plane, it was a statement. The future had arrived, and it had afterburners. Each Concorde seat cost more than first class on normal planes. The cabin had only 100 passengers and no economy seats. Most flights carried celebrities, executives, and heads of state. But that future did not last. High costs, low passenger numbers, and one tragic crash in the year 2000 ended the era of supersonic passenger flight. By 2003, Concorde was retired. The dream faded. Every time Concorde went faster than sound, a thunder-like boom followed it. That noise could shatter windows on the ground. Because of this, most flights stayed over the ocean where fewer people could hear them. So why did it fail? Concorde burned an incredible amount of fuel. It was noisy, both in the sky and on the ground. The sonic boom meant it could only fly supersonic over the ocean. It was also built in the 1960s with analog systems. Maintenance was complex and expensive. The business model never worked. But that is changing now. New materials, new engines, and computer modeling are rewriting what is possible. We might finally make supersonic flight efficient and quiet enough to return. Sound travels at about 1,200 kilometers per hour. When a plane passes that speed, air cannot move away fast enough. Pressure builds and shockwave forms. The moment the plane crosses that barrier, the air splits with a boom. We keep hearing about quiet supersonic jets, but how can something move faster than sound and still stay silent to people on the ground?
Engineers use long, narrow shapes to spread the shockwaves. Instead of one big boom, you get a soft thump that fades in the air. Computers can now model every ripple before the plane is even built.
New planes use carbon fiber and titanium alloys. They are lighter than aluminum and survive the heat that builds up at Mach 2. These materials make maintenance easier and flights safer. Meet Boom Supersonic, a company from Colorado building the Overture, a jet designed to fly at Mach 1.7 using sustainable aviation fuel and advanced composite materials. It will carry 64 passengers and could cross the Atlantic in under 4 hours. The Overture jet will carry 64 people in a long, narrow cabin. The windows are smaller to reduce stress from air pressure. Every part is shaped for low drag and low noise. Boom is not alone. NASA and Lockheed Martin are working on the X-59, a research jet designed to fly faster than sound without a traditional sonic boom. It uses a long, narrow nose to reshape shockwaves, turning the boom into a soft thump. NASA Eurostrade X-59 changes the sound wave itself. The nose is longer than the rest of the aircraft body. That shape breaks the shockwave into smaller ripples that reach the ground as a soft thump instead of a bang. If this technology works, it could allow supersonic flights over land. That would be a complete game changer. Routes like Los Angeles to New York in 2 hours could become real. Analysts expect the first supersonic tickets to cost about $5,000 each way. As production grows, that price may drop to around $2,000. That could open new routes for premium business travel. Airlines are already interested. United Airlines and Japan Airlines have placed orders for Boom Eurostrade S jets, and NASA hopes to collect public feedback from people living below X-59 test flights. They want to prove that quiet supersonic flight is safe, efficient, and acceptable. Many people wonder if supersonic travel can ever make money. What is changing today?
New engines and lighter materials cut fuel use by half. Airlines plan to run on clean fuel instead of jet fuel. The ticket price will still be high at first, but early flights help test what is possible.
Future jets will run on sustainable aviation fuel made from waste oil or algae. It can power the same engines with less pollution. Some companies are also testing hydrogen as the next energy source. Still, there are big challenges. Fuel costs, environmental regulations, and public perception all matter. Even with sustainable fuel, faster travel means higher energy demand. Engineers are trying to balance speed, noise, and emissions. Every new design must prove it can handle heat and vibration at Mach 2. Engineers use high-temperature chambers to test parts before any real flight. Safety is the most expensive part of supersonic innovation. Supersonic flight will always be a luxury for the few, but the same was once true for all air travel. Every new technology starts expensive, then scales down. If we get the science and economics right, supersonic could one day be accessible again. Some experts say faster planes will always use too much fuel. Others believe that as engines improve and materials evolve, speed and sustainability can exist together. Both sides agree the research pushes technology forward. Think about it. A global network of fast routes. Tokyo to San Francisco in 5 hours. London to Singapore in 7. Entire industries could change. Global meetings, time-sensitive deliveries, even emergency travel could happen at record speed. Startups in Japan, Europe, and the United States all build their own designs. Some aim for business jets, others for cargo. The competition is global and each test moves aviation closer to the next milestone. It is not just about speed, it is about connection. Supersonic travel shrinks the planet. It makes distance feel smaller and opportunity larger. So it is not only about speed anymore. What is the bigger picture behind this new race for the sky?
The goal is faster and cleaner travel at the same time. Supersonic flight pushes us to solve hard problems in noise and energy. Those same solutions help normal planes too. It is progress for everyone.
We are living through a time when technology is redefining what is possible. Electric aircraft, hydrogen propulsion, and now, the return of speed. Each one brings us closer to the next era of flight. In the past, designers tested every idea in a wind tunnel. Now they build full digital models of airflow. Each surface is simulated in billions of points. The computer shows exactly how pressure and heat move around the plane. This lets engineers test hundreds of shapes before building one real part. Supersonic flight needs a lot of energy. Today, that energy can come from fuel made from plants or captured carbon. It burns cleaner and can reduce emissions by up to 80%. The engines are also smarter. They use variable inlets to control airflow and save fuel at every speed. So, will we all fly faster than sound again? The answer depends on innovation, economics, and our appetite for change. But one thing is clear, the dream that started with Concorde never truly died. It was just waiting for the right time to take off again. Thanks for watching Inventive. See you in the next episode.